Hello everyone, my name is Sekathalla and today I am going to explain my third capstone project which is about classification. The project name is Credit Card Default Prediction and this project has been done individually by me only. So let's begin. Project summary. As you can see under this project summary, there are three main steps which I have taken to complete this project. That is data pre-processing, exploratory data analysis, supervised machine learning algorithms, and implementation. These are the sub steps under those particular basic steps, getting the data set. For data pre-processing, I'm mentioning getting the data set, importing the libraries, importing data sets, finding missing data, encoding categorical data, data cleaning, and feature engineering. Likewise, here you can see these are the steps I have taken, and then at last I have applied total 5 algorithms to complete this project. Below, this is my GitHub link. Now, problem statement. As the name suggests that this is a credit card default prediction, so eventually we will be predicting the default probabilities of the customers of their credit card payment. As we all know that credit card, if a credit card gets defaulted, then it impacts both bank as well as the customer. In case of banks, it is the financial loss, and in case of customer, it will be impacting their credit profile or credit score, civil score, like this. So for that, the customer will have to face trouble if they have any requirement for a loan in future. So in this project, we'll be trying to predict that how much is the probability for a person to uh, default the payment, or which are the features or which are the particular factors that is being affecting that customer to default their payment. Next, these are the Python library packages, I mean Python packages which I have imported from the Python library, then loaded the data set, then read the data set. These are all basic steps. Then check the head of the dataset. In this section, I would like to mention that since this dataset does not have any particular column name mentioned from its in first column, and it was an Excel file format, so the first row itself was indicating as x1, x2, x3, and x4, like this, and in the next row all the column names are mentioned. So for my convenience, what I have done, I have reassigned the names of the column, each column, as as per my understanding and my convenience, and then drop the first index or first row of that data set, and then check the data set. It will be looking like this. And now check the shape of the data. That is, there are 30,000 rows and 25 columns in our data set. Then check the info. From the info section, you can see all the informations are in object type. So if we apply describe method or describe command to check our data set mean value map, or uh, percentile values or standard deviations, that will not be a good idea. Then check the duplicate values. As you can see, there are no duplicate values. Then also check the null values. There are no null values. So this is the null values visualization. Next, what do you know about our dataset? This dataset contains 30,000 rows and 25 columns, and there are 24 independent variables or features and one target variable, as we know. And basically, till now we have not done anything. Just check the basic dataset and drop the ID column to for my convenience. And default is the target variable which we have to predict. Then check the name of the columns which I have assigned randomly with the random names. Then check the describe, check the data with the describe method. As I have already mentioned that this will not work since all the informations are in object type. Describe method works for only the numerical datas. Next, checking the variable descriptions, mentioning the variable descriptions. So this is the variable description. These are the very straightforward thing. Like maximum credit given means it will indicate that what is the maximum credit amount has been provided to the particular customer. Gender, it will be mentioning about the gender of the customer. It is a categorical, I have also mentioned which are the categorical information. Education, qualification of the customers, marital status, then age, and this pay status I have mentioned as per my convenience, because this pay status means whether that customer paid for that particular month or not. And similarly we have here bill column, which will also indicate that particular month's billed amount. So here bill September means the billed amount of September month, and pay status September means it will indicate whether that customer paid for the September month or not. Similarly, we have payment September, that how much payment has been made for September month by the customer. So similarly, all the other payment and bill and pay status columns will indicate. And at last, we come to the default column, which is our target variable. Here, zero will be mentioning as the indicating that the customer has not defaulted, and one will indicate that yes, the customer has defaulted. Then check the number of unique values. Then these try to visualize some of the unique values, I mean all the unique values. Then comes the data wrangling part. Here I have converted all the information of the data set to a numeric feature. Then I have checked the distribution, I mean the check the data set overview by applying the describe. Now the describe will work, and it will show what are the minimum and maximum value and the standard deviation and the percentile values. So next, I have dropped the id column since it is not important for the analysis, it's the random number. Then again check the head of the data. Now check the values of the three columns which are indicated, which we can see from our describe method, that gender has gender, education and marital status. It has the minimum value as 1 gender, and minimum value 0 for education, and minimum value for 0 for marital status. And I we have checked the number of varieties of values in our in gender, education and marital status column. In gender we can see there are only two values, that is 2 and 1. But in education and marital status there are lot of varieties of values. As we can see, 2, 1, 3, 5, 4, 6 and 0, it is for education, and 2, 1, 3, 0, it is for marital status. So definitely we'll have to do something to fix this, because so many varieties of values will create a problem for the machine learning algorithm. So what I have done, I have grouped the other values, like for education column I have the values which are under 5, 6, which are the least number uh, of varieties, like 5, 6 and 0. I have put them under 4. I have put them under 4. And for similarly for marital status I have put the zeros under 3. So that will indicate other marital status, that will indicate other, because there could be three marital status basically. One is married, second is divorced, and third is uh, mm, third third is other, or any living relationship like this, something like that. So to indicate the other, one is one will be married, other will be not married, and third will be divorced, and zero will be others like live-in relationship. So just put them under 3, under the value 3, to cut off any particular confusion in our data set. Next, what I have done next, I have seen that the p status columns are having three type of values: -1, 0 and -2. So these all values will be indicating that customers have not defaulted. So to indicate that same thing in with one value, what I have done, uh, mm, I have created a group of those custom I mean of those payments which are not being defaulted to -1 for each of the pay status column. So that -1 will be indicating here that the customer has not defaulted the payment. Now next, I try to look into our the pay status column with the describe method, just to see how it is looking like now. So now you can see here that there are total 30,000, and mean value for the pay status September is -0. -0.4, likewise 0.5, -0.5, and then standard deviation. These are like this goes on like this. Next is the see. I have changed the type of the information hmm, in the in the gender, education, and marital status. Because what is the problem, I have indicated these. I have initially I converted all the data in our data set to integer or numeric feature, but these are basically the categorical features, so I have converted back to the object type. Then what all manipulations have you done and insights you found? So first, I have the entire data was changed to the integer type information. I have said that already. Then I have dropped the ID column. Then gender and marital status. I have done. I just I just grouped the other values to a least number of values, and then at last I have grouped the payments which are not defaulted for each month to -1. That is the main thing which I have done, and the manipulations which I have done to the data set. Next comes the data visualization part. So here you can see I have started with the target variable. There is a highly class imbalance. We can see from here. Now checking the distribution of our data set, most of the data are positively skewed, and also there are some data which has discrete values. Now next I check the distribution of our categorical values. This is the distribution of our categorical value. Now next comes the bivariate analysis. This is the bivariate analysis part, to checking the behavior of the target variable in terms of the each individual feature, like default versus maximum credit given, default versus age, default versus the pay status September, likewise. Then similarly I have checked the bivariate analysis for the categorical values. The previous one, this one is for the numeric features only. Sorry, this one is for the numeric features only, and this part is for the categorical features. And then check the correlations. So apart from the in the correlation section, if we carefully see, then we will find that there are no such correlations apart from the billing column informations. So which is quite normal, because billing amount will obviously reflect to the next billing month's billing amount. So there are no highly correlated data in our dataset, correlated individual features. So this is the plot, which is a multivariate analysis. Then comes the checking the outlier sections. I have checked the outlier sections. So we can see from here easily that there are a lot of values which are lying under the outlier section. So to cut short that problem, I have tried with three particular methods. One is min max scalar, like min max applied the min max scalar to the whole data set. I have tried to visualize the columns. Then I see that the problem is not getting solved, the outlier still remains. Then again I have tried the standard scalar method, same thing happened, the outlier remains. Then again I have tried the dataset by converting to the locked in, because since I have initially we have noticed that there are some data which are positively skewed distribution. So none of these methods are working here, as we can see. And also, since there are a lot of null values, so as per my understanding, and as per my I do not have the particular proper domain knowledge about this credit card. So I did not try to uh, remove those outliers, because it may lead to any sensitive information or any important information loss. Next, encoding the data set. Since we have three categorical data here, like categorical data like age, education, and marital status, so I have dummified them. Then feature manipulations, already dropped the id column for our ease of data analysis. Next, again, check after dummification, I have checked the correlation of the data. So the result is quite same. There are no such highly correlated variables in our data set. Then uh, divided the divided the individual section and the target variable section, and then check the number of rows and columns. Then scale the data. Here I have used this standard scaler and applied the standard scalar method to the entire data set, because I have used standard scaler to the data, so that its magnitudes are normalized. This could help learning algorithms and speed up the calculations. Now, data splitting, it is the normalized standard splitting 80/20. Then check the value counts to see the class imbalance. Here you can already, we have seen in the exploratory data analysis part that there is a high class imbalance in our target variable. Similar thing I have visualized. Then applied the first model, which is k nearest neighbors. After applying the k nearest neighbors, we can see that here also one more important thing I have. Since we have a high class imbalance here, so I have considered f1 score to our evaluation matrix, since f1 score indicates both precision and recall. Because due to the high class imbalance, accuracy will not work over here. Because we will get high accuracy for training and test both, but here the main part we will have to concern about the precision and recall. So f1 score eventually indicates both of them uh, with a combination. So I have uh, used f1 score over here. So in the training data set, f1 score is like this, and the testing data set, f1 score is 25, 0.25. You can see here, this is without applying the cross validation factor. So as you can see, without even applying the cross validation, the data which you can see, it is I mean the algorithm has overfitted, since we are getting high accuracy or high evaluation metrics for the training dataset, but it is quite low, very low in fact, for the testing dataset. Next, I have applied the same thing with the cross validation, and after even applying the cross validation as well, we can see the accuracy of or the evaluation metrics for f1 score is not getting improved. The result remains quite same. The data, I mean the algorithm is overfitted to the data with a high accuracy on training dataset. Hyperparameter optimization, here I have used the grid search. And f1 score, I have mentioned that there were no improvement. So coming to the next model, for our next algorithm, that is logistic regression. First, I have applied the logistic regression without the cross validation factor. Without cross validation, you can see the f1 score here is 36 and 36. That means the accuracy is, or the evaluation matrix is not a good number for this particular. Here that algorithm has not overfitted, but the evaluation matrix number is not very much convincing. That is without the cross validation. Now check the ROCAUC curve and see that it is 0.64. It is quite convincible, but since we do not have a good number for the F1 score, so we cannot also consider that part, that logistic regression with the cross validation. Next, checking the classification matrix, it is also uh, not bad, but for F1's, if since F1 score is indicating very low value, so we cannot consider this result is same. This is classification matrix for the test data. Then apply the same thing uh, with cross validation. So after applying the cross validation, the ROC AUC score remains same, and also the F1 score remains same remains same. So there is not much improvement in the training or testing data set after after applying the cross validation. So I have come to the third algorithm, which is decision tree without cross validation. We can see the F1 score is 99 for the training dataset, and for testing dataset it is quite low, which again indicates that the algorithm has overfitted the data. That means it has the algorithm has learned all the patterns of the data, everything in fact. So next I have tried the decision tree with the cross validation. Even after applying with the cross validation, the number is improved a little bit, 50% for the 50 for the training data set and 47 for the testing data set. But still we need to have this F1 test score at least in the range of 50 to 60, then we can consider that a particular algorithm at least. So after applying the decision tree, there is a bit improvement in the with cross validation. There is a bit improvement in the evaluation matrix F1 score. Then coming to the next model, which is XGBoost, and that I have applied XGBoost directly with the cross validation. And before applying XGBoost with the cross validation, since there is a high class imbalance in our data set, so I have used the SMOTE technique to sample oversample the data. SMOTE means the synthetic modeling oversampling technique. So after applying the SMOTE technique, I have applied the XGBoost and then check the evaluation matrix of which is F1 score for our data set. And again we can see that the F1 score is not improving, it is again a kind of overfitted, because we are getting high accuracy for training data set and low accuracies and the low evaluation metrics, actually low F1 score for testing data set. Then again same thing, this is the classification confusion metrics ROCAUC curve. It is the score is good for ROCAUC. Then at last I have applied the random forest classifier directly with the cross validation, and here we can see applying the random forest classifier with cross validation. We have the F1 score. We have the F1. We have the F1 score. We have the F1 score. We have the F1 score in the range of 50 to 60. 0.53, yes, here it is, 0.53 for the testing dataset, and trained dataset it is 0.62. So we can consider this F1 test data F1 score at least for this particular algorithm, and we can accept this algorithm at least. Then again I have checked the confusion matrix. Here you can see 3095 3956 956 records have been determined correctly, and these are 576 731. These are actually predicted incorrectly. These are the records, which is not bad at all. And again I have checked the ROC AUC card, it is also good. And at last I have AUC card, sorry, and at last I have the chart of all of our evaluation matrices, that without and with cross validation. With each model. So here also you can see, you can summarize that for random forest classification classifier model, which is with cross validation hyperparameter tuning, we had 0.62 evaluation matrix F1 score and 0.53 for the testing score, which is quite acceptable. I have already mentioned the reason for considering F1 score as our evaluation metric, since it is convinced both precision and recall. Next, since we have a better accuracy number for evaluation, sorry, F1 score number for random forest classifier, so I would go with random forest classifier for as of now, because since there are highly class imbalance data in our data set, so this particular so all of our models will need more data to learn the more patterns to understand the default default prediction. However, the data here was quite big, but there is a very low number of default patterns or low number of default uh, mentioned in the default column. So that is the main problem. But however, we have tried couple of techniques to cut that problem. But at last, I would say that we need more data to learn, so that our algorithm can have the opportunity to learn more about the default patterns. Now comes the conclusion from the EDA. We can see that the gender has two more frequent gender 2 has the gender 2 has more, actually the gender column has two values, 1 and 2. So the gender which comes under category 2 has more frequent habit of taking credits in education column, marital status column, and education marital status column. In education column and marital status column, the education 2 and marital status 2 has more uh, habit of taking credit. Again, apart from billing to September columns, there are no highly correlated data, as I have already said. There is a high class imbalance in our data set. There are a lot of outlier values in the data set. So due to, as I have already mentioned, due to the less domain knowledge about the about this particular factor or sector, and also since and also there could be a important information loss if we try to delete the outliers. So I did not do anything to the outliers. I have considered all the informations to our dataset, and at last I have used before I have also used the weight class to handle the class imbalance. I have used the distance balanced and smooth technique, and I have implemented 5 classification models, and from that the random forest classifier performed best as of now, since it has got the F1 score as 54% compared to the all other models. So that's it about my project. Thank you.